Today we will start with Docker. First we will install Docker and we will try to get familiar with it. I don't know if you have ever used it before. Even if you have used it, maybe you can learn a couple of things. We will install Docker with packages, with the Debian packages. And let me get the key first from the from the notes here. So first with wget we are going to get this GPG key, and we will store it into this path, into this location. So this capital O option is for storing the file into this location. So let me copy this command. And let me check whether it is downloaded. Okay. And now we are going to create this docker.sources configuration file into sources.list.d. And let me look also with nano. So it is getting the packages, the Debian packages from this URL, suite Trixie, components stable, and signed by, this is the key that we downloaded a little bit ago. And now apt update to get the list of packages in this repository as well. And now we install these packages. Apt install Docker Community Edition, Docker CLI, container d.io, Docker BuildX plugin, and also Docker Compose plugin. So we are installing at the same time Docker Compose, which is a part of Docker now. Let us check with the Docker version. So it is already installed. Also Docker Compose version. Docker Compose is installed as well. System control status Docker. There is a service. Docker is running a service named Docker, and it is already running. And now we can run a simple Docker command. Docker run hello world. Now let's try this and see what happens. So it tries to build an image, a container based on this image, the image that is named Hello World. But it is not able to find the image Hello World latest in the local repository in this VPS. So it is pulling it from library Hello World from Docker Hub. And after downloading the image, this is the new image. This is the tag tag. If there is no tag specified, then the default tag is latest. And after downloading the image, it is running a container based on this image, and then this image specifies a command inside, and the command inside the image is being executed, and the command inside the image just displays this this output, this message: hello from Docker. This message shows that your installation appears to be working correctly. And it also explains what happened. To generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. The Docker daemon was the service that we checked with Docker control, dockerctl status Docker. So the command, this command Docker is the client. It is contacting the Docker service that is running in this VPS. The Docker daemon or the Docker service pulled the hello world image from the Docker hub. The Docker daemon created a new container from that image, which runs the executable that produces the output that we are currently reading. So inside this image, there is a command or a script that is being executed, and this script produces this image. The Docker daemon streamed that output to the Docker client, which sent it to your terminal. To try something more ambitious, you can run an Ubuntu container with docker run it ubuntu bash. Okay, we can try this command, docker run now let me try to explain this command. So docker run is the same as before, same as docker run hello world. So it is running, it is creating and starting, creating and running a Docker container. Now this is the image. This container will be based on an image that is named Ubuntu, and this image is not available here, so it is going to pull it from the Docker hub, and it will be Ubuntu latest because no tag is specified, and inside when the container is running, it will run the command bash inside this container. So after the container is running, this command will be executed inside the container. So because we are executing the command bash, we get a shell inside the container, a prompt. So here at this configuration file, we can check the version of Debian or Ubuntu, and it is Ubuntu 24, etc. Now we can use exit to close the command bash, to exit from bash, and then the Docker container is stopped. Now let's try another Docker command. Docker run name test1. Now again we are creating and starting a Docker container. This time we are specifying the name of this container. So the name of this container is going to be test1. In the previous examples we did not specify a name for the container, and as we will see later, it assigns a random name to these containers. But for this case we are specifying that the name of the container is going to be test1. and the image of the container will be Debian 13. This is the tag. This is the name, and this is the tag. And after the container is started and running, it is going to execute this command inside the container, which should print this text message. So after pulling the image, it starts the container after pulling the image, and then executes the command echo hello world, and the result is in this line here. Now let's see this docker image ls. This is listing the images that are in the local in this VPS, that are downloaded in this VPS so far. So we downloaded an image for the hello world container, and the tag is latest. We downloaded an image for Ubuntu. Actually, these were downloaded automatically, and also this image was downloaded as well for starting the latest container. Now the command docker ps is showing the list of Docker containers that are currently running. None of them is running, so the list is empty. But if we use the option -a, all, this is for all, it is going to show also the containers that are stopped right now. So there are these three containers. So container ID is the first column. The image is the second column. The command that is executed inside this container is this one, for example. For the hello world, we use the command bash for the second example, and we use the command echo hello world for the third example. And this is the time when the image was created. 7 minutes ago, 3 minutes ago, about a minute ago. And status, all of them are exited. So the aim of a Docker container is to execute a command. And as soon as this command is finished, the Docker container itself is stopped. If the command keeps running, then the Docker container is still running. And we noticed this with the bash example. So when we started a bash container, it gave us a prompt, because this is what bash do. It presents the user with a prompt and waits for the command, for a command. Executes the command and again the prompt until we exit it. We typed exit and the bash command was terminated. As soon as the bash command was terminated, the container itself was stopped or exited, terminated. Now let's try another example. Docker run name test2 Debian 13. So this is the image, and the command inside this container will be bin ash So we are creating an image, a container with this name, test2. And I forgot to show here that the last command is the name. And the name of the first example was Eloquent Brown, a random name that is assigned automatically by Docker. The name of the second container was Vigorous Kepler, again a random name assigned automatically. And for the third case, the name was test1 because we specified with the option name what is going to be the name of the container. In this case, again, we are specifying the name of the container, test2. It is the same image as before. So this time it does not have to download it because the image is already present in the current in the local repository of images. And then it is going to execute this command inside the container. This is a shell, and it will execute this command inside the shell. While true, which is an infinite loop, do. We'll run the command date, sleep 1 second, and then it is going to repeat this indefinitely. So this time it did not have to download an image because the image is available. So it just started the container named test2 and started to execute this command inside the container. And the command keeps running because it is an infinite loop. We can stop it with Ctrl+C. And each step of the loop is running the command date, which shows the current date and time. So it is the command date which shows the current date and time. Now, in the list of images, we also have this one. There are four containers. All of them are stopped because the status is exited for all of them. But we can start a container with the command docker start. For example, let's start this container, test1. And this test1 is just going to print hello world. Docker start test1. And did it print hello world? Yes, but actually it is started when it is started like this. It runs in the background, and all the output is in the background. So let us look, with docker logs test1. So this command docker logs is showing the messages that are coming from this container, the container named test1, and it is displaying only this message, hello world. And with docker, we see that test1 is actually stopped because even if we start it, it executes the command is terminated, and it again stops. So if we start it again another time, docker start test1, let us look at the logs. Now we see from 2 lines, now there are 3 lines. The last line was produced by the last execution of this container. Now, if we start test2, for example, this test2 is running this infinite loop, but we don't see any messages here because it is the output from the Docker container are being stored into the logs for this container. It is kind of running in the background. It is running as a daemon, as a service. If we run docker ps, now we see that this container is still running. So status is up since 27 seconds. So it is still running. And if we look at the logs for this container, we see all these messages that are produced by the command that is running inside the container. these messages can be just plain messages, standard output messages, or standard error messages. Also, the error messages are being stored to the logs as well. And if we run the command docker logs, but we append the option -f, then it is going to follow the logs. So it keeps looking at the logs until we stop it. We can stop with Control C. Now, this container test2 is still running. It is up. But we can stop it with docker stop test2. So this command stop should stop it. And if we check again with the command, the command docker ps, now we see that it is not running anymore. So it is stopped. This is test2. It has exited. It is stopped. Now let's try a third example, or another example. Docker run name test3. So I'm creating and starting a container named test3 based on the image Debian, and the command inside the image will be bash. I'm using also these two options. This is for interactive, and this is for terminal. So it is attaching a terminal to this Docker container, and it is allowing interactivity. So it will attach my standard input, which is the keyboard, to the container, so that what I type in the keyboard goes to the command inside the container, and it will going to attach also a TTY or a terminal to this container. And this is so that it provides interactivity, so that if I type a command, the command will go so that I can interact with the command that is running inside the container. So this is similar to the example that we used previously with Ubuntu. Or we can try something else here. The command ps is not installed, but we can install the command ps inside the container. Apt update, and then we install this package proc ps, which contains the ps command. Now it is available. This command ps with the options AUX is going to list all the available processes. And we see that in this container there are only two processes running. One of them is the bash command itself, or the bash process, and the other one is the command that we are running from the bash. We are starting from the bash. And the main process of the container, the process that the container executes when it starts, has process ID 1. It is the root of all the processes inside this container. exit, we terminate the shell, and so the container is stopped as well. So the container has stopped also. We see all these images, Debian latest. This is Debian with the tag latest, and Debian 13. But actually, if we look at the ID of these two images, they are the same. They are the same image, because the ID is the same. Now, this container is stopped, but let's start it again. Test 2. It is running. It is producing some output, but it goes to the logs of this container. We can do something else. We can, for a running container, we can execute a command inside this container. And we can do it like this, docker exec. This is for interactivity, because we are going to execute an interactive command inside, or let's try a non-interactive command first. Docker exec test 2. So I am executing inside this container, the container named test2, this command. Now, if I want to execute a command like bash, which is an interactive command, it expects some input from the keyboard and shows some output to the terminal. Then I have to use these options -i and -t. So now I'm running another command inside this container. And
but now
yes.
But now there are two shells in the same container because it's still running the script of the date.
Yes, the command ps aux is listing all the processes that are running inside this container, and we see these are the processes that are running inside the container. The process number 1, or the main process of the container, is this shell, and this shell is running this infinite command inside it. But also we started another process with the command exec. So docker exec started this other process, or this other command inside the Docker container. Actually, this process is coming is generated from this one, because there is a sleep subcommand here. And this process is the command that we are running here. So right now there are two main processes, this one and this one, that we started with exec. But we were able to start it because the Docker container was still running. So if the Docker container is stopped, then we cannot just run a command inside it with the docker exec. If the Docker is stopped, we cannot execute a command inside this container. If the Docker container is running, we can execute another command inside this container. And this is useful, for example, to debug some containers. So we run a bash shell inside a Docker container, and then we can check the status of the container, the configuration of the files, etc., to figure out what is not right, or if something is going wrong. Is it clear?
Yeah, but another thing is strange that you had to install another time the package for PS.
Okay, this is not strange because we installed it into test 3 last time. We did not install
Okay,
it.
okay.
This is test 2. This is
Test
another
2.
container. So
Sorry.
if I exit now, I'm exiting from the shell. The container is still running. I can execute again bash. I can enter again inside this container by executing bash inside it. And if I check the command ps, it is still there. So first time we installed it in another container. So this is why we had to install it again inside this container.
Thank you.
And we can use, for example, the command top. Inside this is inside the container, and there are just 4 processes. So there is not a long list here, just a very short list. And we can check, for example, 3H. This is showing the memory usage, RAM. And I see that the total amount of RAM is 4 gigabytes, used this much, free this much, and so on. This is telling me that the container is not like a virtual machine. Because in a virtual machine, you allocate some resources, some RAM, some disk, etc. to the virtual machine, and these are limited. So if I have a VPS of 4 gigabyte RAM, I cannot run a virtual machine of 4 gigabyte. It has to be less, 2 gigabytes or 1 gigabyte or 512 megabytes. But in the case of container, the container actually is not like a virtual machine. The container is the Docker containers are based on special features of the Linux kernel, and they just isolate one process and one file system. So the image of the container provides the file system, and the command inside the container is the system that is being executed. And the kernel, the Linux kernel, provides some isolates this container from the rest, from the host where it is running, for example. But actually, the kernel inside the Docker container is the same kernel as the host machine, as the VPS in our case. So there is no kernel inside the container. The kernel of the host is also executing the processes inside the container. I don't know if this makes sense, if this clarifies anything. And also, if we check the space, the disk space, we see that the size of the disk is 38 gigabytes. This is the size of the VPS, the amount of disk of the VPS itself, of the server itself. So we have not, when we created the container, we did not impose any restrictions or any limits, so it can use as much as he wants. Now we tried this command docker psa, and it is listing the containers, all the containers, even the stopped ones. with these fields, container ID, image, or these columns, command, created time, status, ports, which is empty for all of them right now, and names. But we can change the format of display. For example, Docker PSA with this option format, and this is getting the field ID, and let's get also the name of the container. It is names here, names. So this is listing only the field ID and the field names. And this is just a separator between these two fields. And so this is the ID of the container and the names. Test 1, test 2, test 3, and these two random names. And let's try also the command history. So we are looking at the history of this image. Docker image, history, and the name of the image. And the command history shows us the commands that were used to create this image. So first of all, there is a copy command that is copying this script or this command named hello inside the container, and then this is telling the image that the default command to be executed is this one, hello. This was the hello image. Let's see this Docker inspect. Test 1. This Docker inspect shows us the configuration for this container, and it is in JSON format. And it is a long one, that's why we used less to have a look at it. It has a lot of settings. And let's look at test 2 as well. So here is, we see here, for example, path and arguments. So this path is the command that is executed inside the container. And these are the arguments of this this command. So it is taking the argument C and also this small script. And also the state status is running. This one is still running. We started it a little while ago. So there are lots of information here, but right now we don't need them. Just to have a general idea. And the command docker has also some other subcommands that we can look with help. Actually, it has a lot of subcommands. We have tried this run, which creates and run a new container from an image. We tried this exec, which executes a command in a running container, So the container has to be running. And the command ps is listing the containers. We will see an example with build soon. And also this to manage images, image ls, list images. And if we want to know more details about one subcommand, for example, what are the options of the subcommand run, we can try it like this. So it has actually a lot of options. So docker run, the name of the image, the command that is going to be executed inside the image, and any optional arguments. And also the command is optional because in the image definition, maybe we can set what is the default command. So if no command is specified, then it is going to execute the default command that is specified inside the image. And the options are lots and lots of them. There is no chance that we can review all of them right now. And now let us do some cleanup. Let us remove the test images that we have created so far. First of all, let me stop this container, test2. Because it is still running in the background. Now, I can remove these containers by name. For example, docker remove test3, test2, test1, and also these two images, these two containers. So they were removed. If I look at the list of all the containers, now it is empty. I can also remove the images that are downloaded so far. Docker image remove, or also this command works, docker remove image, and the name of the image, for example Debian. This will be Debian latest. If we don't specify a tag, then it is latest. Debian 13 hello world, and also this one, images removed. Now the list of images is empty. Now let's download an image that runs a web server. Docker, first of all, we are going to search. So in the Docker Hub, there are lots of images, and we are searching in the Docker Hub for images that are named Welcome to Docker. And we are limiting the output to 5 lines. So there are 5 options here. And there are several images named welcome to Docker. This is created by this user, for example. This is created by this user, but this is an official image. Docker welcome to Docker. So we can download this image, and we can download it with the command docker pull. Either Docker welcome to Docker, or if we just leave out this, it will be the official image, Docker welcome to Docker. Or a repository does not exist. Okay, let's try this, Docker welcome to Docker. It is downloaded, and now let's just have a look at the history of this image. Docker image history, and the name of the image. So these are the commands that are used to build this image. These are Dockerfile commands. We are going to see an example Dockerfile a little bit later. It is starting from Alpine, which is a kind of minimalist Linux distribution, which is popular for building Docker images. It shows that the default command is bin sh, and then maintainer, nginx docker maintainers, nginx version. So this is basically an nginx container. It is running nginx inside it. This command copy is copying some scripts inside this container, inside the image. So these are the commands that are used to build this image. And this entry point is also a default command that is executed when the container starts, if no other command is provided. And expose, it is the port that is accepted by this Docker container. It is accepting the port 80 because it is an web server. And again, we see the default command here, which probably is overriding the previous one, and the default command is nginx. So it is basically an nginx command. So let's start a container based on this image. Docker run, name nginx, port 8081 to 80. I'm forwarding the port 8081 from the host to the port 80 in the container. Or the Docker is going to forward it. I am telling Docker to forward this port. And the image is Docker welcome to Docker. And I'm not specifying a command here because the default command is to run nginx. So just enter. So nginx is running. So these are the messages coming from the container, and nginx is running right now, and we can try to open in browser the website in this port, the website provided by this container. So let me try, for example, nginx.user1.fs.al at port 8081, and it is HTTP, not HTTPS. And this page is actually provided by this container. Congratulations, you ran your first container. This is an example container. And we also see here the logs. So it is displaying the logs of nginx. Now I will press Ctrl C, and this will stop the container. And I will call again the previous command, but this time I'm going to append I'm going to add the option -d. The option -d is for detached or daemon. So the container will be executed in the background, and we will not see these messages here. So okay, I'm trying to start another container, a second container with the same name. And this creates a conflict. So let me remove this container first and create it again. So docker. We already have a container with this name. So let me remove it first, and then try to start it again with the same name. Create and start. And now it is running in the background. We don't see any log messages, but of course we can access the log messages with the command docker logs nginx and also follow. So here we have the logs of the container, and if I refresh the page here, I will see these other messages that are appended to the logs. Refresh again. Okay, Ctrl C here. Now the container, the nginx container is still running. We can enter inside this container as usual with docker exec. The command bash is not found. Okay, maybe because it is a minimalist. Okay, we can use this /bin/sh shell and cut OS release. It is an Alpine based Linux. These are the processes running inside this container. This is the main process with process ID #1, and it is also starting these other nginx worker processes here. And this is the shell that we are running here and the command. This is the list of all the processes. The configuration of nginx usually is at this directory. this is the default configuration. We can look inside it with less. So this is the configuration of this website. We use Q to exit from less and then exit. Now let's stop this container and remove it. Remove image. And now this should not be available. So it is trying to access this port 8081 and it is trying and trying, but actually this port is being stopped by the firewall. So if we look at the ports that are open in the firewall, there is no port 8081. So that's why this cannot be accessed right now. Firewall CMD. The active zones of a firewall are Docker and public. There are some other zones, but they are not active because no interface is being used by these zones. The Docker zone is using the interface Docker 0, which is created by Docker. So there is this interface Docker 0 that is being used by Docker containers. And if we list zone Docker, here the interface Docker 0 is being used by this zone. So it is still trying to access this website, but the port 8081 is blocked on the firewall. It is not allowed. So it does not even say that the site is not accessible or failed to access the site. And it happens because the default policy of the public zone is drop. So it does not reply. It does not say to the client that you cannot access this. It just drops the packet. And so the client tries again and again and again until a timeout. So now we have this site can't be reached. The timeout took too long to respond. And this happens because this port is closed on the firewall, on firewall D. But while the container was running, we were able to access this port. Is this not strange? How did this happen? This happens because if we recall, let's try to recall the command that we started. So this is the command that we used to start the Docker container. This option P is forwarding the port 8081 from the host to the port 80 into the container. And Docker makes sure that this port is open So no matter what firewall we have, Docker is using another zone, and it will allow this port to reach the container. So if we make public a port in a Docker container, so if we publish a port in a Docker container, this is open for everyone in the internet. Everyone in the internet can access this port. So we should be careful about this. We should know about this. So no matter the firewall does not prevent Docker, does not protect Docker. This firewall that we are using here protects the host, but not the Docker containers, because Docker will make sure to open this port. If we tell it forward this port to the container, it will make sure to open it, no matter from the firewall. If we want to have a strict control of which ports are allowed and which are not, then we should use an external firewall. For example, Elsner might have a firewall in front of the VPS, and we can use the Elsner firewall to say block all the ports but allow only this and this and this. And in this case, Docker cannot do anything to bypass the Elsner firewall, the provider, the service provider, VPS provider. Another way to make sure, for example, if this port 8081 should be available only for the applications inside this VPS, but not from the internet. If we want it to make available only locally, then one thing that we can do is to restrict it like this: 127.0.0.1. So we are telling the port 8081, but on this interface. So if this port is accessed in this interface, it will be available. If it is accessed in the public interface, it will not be available. So we are restricting this port. So this also works. Now this port will be available locally. For example, I can try to access the website, this one, with curl, for example, from inside the VPS. Curl. It is still trying to access it from the public IP because I'm using this. But let me do a trick. I will copy this. And let me use nano. Now, if I try to access it locally, it will try it on the local host, and then it will retry the website. But if I try to access it from outside, again this port is not accessible from the public IP. So let us stop here, and next time we will continue with another Docker example.